Hi, it's Mr. Fletcher here. We're going to be looking at probability tree diagrams again. This time they're going to be complicated tree diagrams or conditional tree diagrams. So we've got a problem here where we've got 5 red pens, got 3 blue pens and 2 green pens in the box. So if we add all the pens up, we know we've got 5 and 3 and 2. So we start with 10 pens. Okay, we start with 10 pens. Now Jerry takes at random a pen from the box and he gives the pen to his friend, and then he takes at random another pen from the box without replacing the first. So there's a key bit of vocabulary in the question. We are not putting that pen back in. So the second choice pen, there's less pens in the box to choose from. Okay, so let's have a look at this. So the first thing I'm going to do is we're going to complete the tree diagram. Now, strictly speaking, we don't actually have to complete the tree diagram for this question, but I think we're going to do it anyway so that you're familiar with how to do it. So if we choose do the first choice, then we've got red, blue and green, red, blue and green. So probability of getting a red is 5 out of 10. The probability of getting blue is 3 out of 10, and the probability of getting green is 2 out of 10. We then, I guess, need to draw in the rest of our choices down the way. So we've got some choices there, some choices here. So we're just getting all the outcomes drawn in. So what can happen? We've got red, blue and green in our second choice, and red, blue and green, and red, blue and green. So there's only 9 pens left for second choice, because we've not put it back in the box. So I know that my red pens, so I had 5 red pens and I've taken a red pen. Now there's only 4 red pens and there's only 9 pens in total. So here we started with 3 blue pens. I've not taken a blue pen up here yet. So there's 3 blue pens, but there's only 9 pens. And green, there's 2 left out of 9 pens. And then we fill this one in. I've taken a blue one, so there's still 5 left of the reds, but only 9 pens. Now here, I've already taken one of the blue ones out, so if I get to this point, I've only got 2 blue pens out of 9. Green, still got 2 here out of 9. Red, still got 5 there out of 9. Blue, still got 3 out of 9, but the green ones, I've already taken one of the green pens, so there must only be 1 out of 9 left. So we've completed the tree diagram, even though we didn't really need to do it for this question. So we need to work out the probability that both pens are the same colour. Okay, so red and red, yeah, we'll have that one. Blue and blue, I'll have that one, and green, we'll have that one. Now when we're going along the branches of probability, we are multiplying, okay? So we need to do 5/10, and I'm going to multiply that by 4/9. And here I've got 3/10, I'm going to multiply that by 2/9. And here we've got 2/10, I'm going to multiply it by 1/9. So they're my probabilities for the same coloured pens being chosen. So what's on the denominator? 10 times 9 is 90. 5 times 4 is 20. That's going to be 6 over 90. That's going to be 2 over 90. Okay, so the probability that the pens are the same colour, so whereas we were along the branches we were multiplying, now we're at the end, we're adding up things that we want to bring together. So I need to say the three things I'm interested in are 20 over 90. I'm going to add that to 6 over 90 and 2 over 90, which is going to give me 28 over 90. And for probability, we do not need to simplify that fraction. Now, the probability that the pens are not red, that both pens are not red, well, I already know what the probability for both pens being red is. So there's a bit of a trick here in the sense that all the rest of this here is the pens not being red. So I could work out all the individual probabilities for all these parts of the tree. Or I could just say that I know all of the probabilities down here that I've not even calculated all of them yet, but if I added them all up, they would add to 1. So if I say I just don't want this bit here, the red option, then it must be 1 take away 20 over 90. So 1 take away 20 over 90. But I could say it's 90 over 90, because that's just 1 take away 20 over 90. And that is going to be 70 over 90. And then for this question, we are done.